So, good evening again to everyone. And I'm going to talk about regression, simple regression. That means there's a one dependent variable and one independent variable. And let me explain the basic concept and then we will do on Minitab. Okay, right here. Let's say if you plot a graph on two variables, X and Y. Let's say your salary or job offer letter or salary, I would say, offered So if you do like this, after graduation, after MBA, you try to change job and you get new job offer and you get a salary offer. And this is salary. And I'm just going to, so one more variable, let me see this chat. Okay, and this is your GPA. Let's say this is your GPA and this is salary. So basically, if I draw a graph, let's say this is coming based on data like this. Then this is called intercept. This distance is called intercept. Can you hear me? You want to log in?
Thank you. Hear you. I can hear you.
Oh, perfect. So those who cannot hear, I would request you to log out or log in or just try to see your microphone. Yeah, I'm just waiting a minute so you can restart or do whatever. Should I proceed? Okay. So this is called intercept. That means, and you put the point on anywhere two places on this line. So I put like this and I put here. And you draw perpendicular and horizontal lines. So this is this, then I draw like this. So this is Y2 and Y1. This is X2 and this is X1. So this difference, and this difference. So this is called slope. Slope equal to, here del y or difference in y divided by difference in x. So how to calculate slope? So this is just two dimension, means your salary depends on your GPA. So you can get this intercept, you can get this slope, and the equation of this line is this. The equation is equal to y equal to intercept plus slope multiplied with GPA into GPA. Is it making sense to everyone? So, or this is line y equal to a plus bx. In simple form, we write this equation like this, where a is intercept, b is slope, x is your GPA or any independent variable. So is it making sense to everyone? Then I can proceed. Yes. So we are going to learn, we are going to identify this, we are going to identify this, and we are going to see our model is validate to predict something or to forecast or to. So now I'm going on the Minitab. Okay. Okay, here we go. So basically this is chance of admission. Let's say chance of admission in any university depends on your GPA. So I'm going to make a model and I'm going to see this model is validate or not. Okay, so I go under statistics. I use regression. Fit regress. So we are going to use only one method called OLS, ordinary least square method. And we will learn more in next class, which is 520. So here we go. Response means dependent variable. We are going to use only one. So first is where is a chance of admission, and this is GPA. And before going into this, I do, and these are all, so I'm just going to do this thing. Now here you have the numbers. This is your chance of admission, like we got the equation, like I said, this is minus, okay, let me see. This is our intercept. This is 0.209, this is slope. And chance of admission, so we got our equation. Now we want to see whether this is regression model is valid or not. So there is a null hypothesis and alternative hypothesis. Null hypothesis is intercept. Okay, I can see H0 is all constants are 0. Are 0. Alternative says all constants are, at least one constant is not 0. At least one is non-zero. I hope I am recording. Just a minute. Let me check because yeah, non-zero. Now look into that. So you remember last class, what do you conclude in this? Because this is a constant, this p-value is this, GPA is this, and this is a p-value. What do you say? Use the rule that we use in the last class. Any answer?
Would it show a statistical significance because it's at 0.00000, which would be less than the alpha or whatever?
Yeah, so which, this is correct or this is correct?
The alternative hypothesis, I think.
Yeah. Null says this is all constants are 0, means, so alternative says at least, so means the, so basically in this model, in other words, this I would like to say useless. If something is 0 means useless, and I can say this is useful. So basically with this p-value, as you have confirmed, that these both constant and GPA, they are useful in this model, means this model is good for prediction. Now we come to the other part. Okay, so you understand what is the meaning of null and alternative hypothesis. I'm going further. So here we go. So we learned this. Yeah, there's also one relationship. Okay, just so coefficient and this coefficient and this, these are having relationship. Coefficient divided by standard error of coefficient becomes t-value. How? I can show you. So let me start with calculator. So you can see my calculator
No.
now. calculator is not visible to you?
No, the calculator is not visible. Minitab is.
Okay. 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 So, okay, let me do this way. So t equal to t value is minus 1.0443. This is the value that coefficient divided by standard of error is 0.0423. Is it correct? So if I use calculator and I do this, maybe you will not see my calculator, but yeah, so this is going to be, okay, just 1.0443 divided by 0.0423, we are getting 24.69 value. I mean, if you do this, I mean, so this divided by this, you get this. So basically, if you have this value, any two value, you can calculate third value. Is it making sense?
Yeah, that pencils out.
Yeah, so this divided by this, you get t value. So any two value, you can calculate three value. If somebody says coefficient and standard error of coefficient is given, you can calculate t value. If t value and standard error of coefficient given, you can calculate coefficient. Eric, what did you not? Any question, Eric? Okay. Okay, so here we go. Now we come to this model. So here this is I'm coming over there. This is R square. This is R square is called coefficient of determination. Coefficient of determination. Please, and it is 77. Means how do we interpret? Chance of admission. What is our dependent variable? Chance of admission. 77.87% depend on your GPA. Or in other words, 77.87% change in chance of admission is due to GPA. Or change in chance of admission can be explained by GPA by 77.87%. So R square value can be 0 to 1, where 0 is no relationship, 1 is 100%. So there is a regression and there is a correlation. So some people, so a small r equal to correlation. And R square is for regression. Okay. What is the difference between this? In simple regression, correlation into correlation, you get R square. And I will show you here. Just a minute. Okay, so let me share my screen. Just a minute. Share and screen 2. So now I am going to do correlation. How do we do correlation? Basic statistics. And here we have correlation. What are the two variables through we are doing chance of admission and GPA? Okay. Results must be pairwise correlation and okay. So you see this is a correlation and you can see the correlation GPA. What is this correlation? is 0.882. Correlation is 0.882. Okay, so now I'm going to see calculator and point. Can you see my calculator now?
Yes, we can see it.
0.882 multiplied by 0.882. What do you get? 0.77. And this is what is our point. This is 7787. So 7779 is 8. So basically R square, you can see exactly there is some roundup and things, but this is the, so if you do the correlation, for this is only valid for simple regression. It is not valid for multiple regression because there is, different equation. So if you know R, you can do R square. Now you go here. So R square is this, means 77.87% change in chance of admission can be explained by GPA or CGPA. What is adjusted R square? Adjusted R square is always little bit lesser than R square. That means if R square is, just a minute, R square includes everything in the calculation, but adjusted R square refine it, filter more, it includes more filtration. Therefore, this is always little bit lesser, and R square, this is more less. I mean, this is again, so this is complete, this is more refined, and this is more refined. How? You can see here. So fits here, you can see. So because these observations are unusual observation, and these might be reduced from R square adjusted. So some errors, some unusual things is reduced, and this is not required. So this is R. So this is deviation in the total regression, and this is called overall regression is valid. Here this is the F value, P value. So P value is less than, means this is useful. So overall, this is useful, regression is useful. And now we go to under this, this is unusual observations, means you can see these observations are not fitting with the line. Maybe you did some wrong entry of the data. Maybe this is unusual behavior, any reason could be. You just go and check your entries. If these are things you can clear out, you can filter out these numbers because some of them are this. So what are those residual? I mean, I can just show you. So let's say this is your regression line, and real observation are like, these. Just, so one is this difference from real line. This is positive. Difference from this real line is negative. So these are the things. This is residual, and standard residual, again, Z equal to mu X minus mu divided by sigma. So this is standardized. This is a fit value for this. Fit value means for this, like this is the fit value. This is a fit line. Is it making sense to everyone?
Yeah, so the standard residual is basically the distance between the standard line and then the points, right?
So residual, so basically, let's say this is a standard line, and this is an observation, and this is residual. How do we do standardized? You remember that standardized value?
Oh, right.
Z equal to X minus mu divided by sigma. So you have all the, because, this is this is this for all observation, 500 observation, you check mu, you check thing, you can do easily. Now I can do here, just a minute. So let me do the residual. So I go under statistics, regression, fit regression model. And here I have the options, graph, sorry, I have results and Darwin Watson I can store. And here, here you can see fits, residual, standardized residual. Okay. And okay, here we go. So this is the fit value, and this is residual, and this is the standardized residual. So if I do the standardized value of this, I will get exactly this. Standardized, you know, z equal to x, the same formula. Is it making sense?
Yes, sir. Thank you.
You're welcome. So yeah, this is regression, and yeah, we will do multiple regression in next class. So this is an observed Darwin-Watson test is usually used for you know, time related data. So we are not going to use as of now. Just, you know, few question, you know, one question is based on this value. In fill in the blanks, you have to read the chapter because, you know, few assumptions are there based on the chapter. So read few points because few questions are based on that. If you have any question related to this module, because we are not including in final exam, you can always reach me. If you
And-
have.
Oh, real quick, sorry. Are we utilizing the R squared or the adjusted or the predicted more often?
Okay, so, you know, R square is commonly used, but some people use adjusted R square. Suppose you have multiple regression. So basically R adjusted some. So these are the two numbers. If question is asking adjusted R, you have to give because this is more. Suppose you have 10 variables, so 5 variables here. One is not significantly important for prediction. That, you know, this it's means it rectified all these errors and other things. So this is more fine or more precise value. But, you know, it is very less, you know, a little bit lower, but not like, you know, if this is 77 or 78%, it cannot be 72%. Maybe 1 or 2%, not much more. But, you know, if you have only a small number of observations, then it could be significantly different. But, you know, this is most important. R square is most important.
Got it. Makes sense. Thanks.
Most welcome. Any other question? If you don't have, I would like to say wonderful evening and wonderful productive week. And, you know, have a great summer, and we will meet again during, you know, 2024.
So I just wanted to clarify, this chapter is, you said it's not going to be on the final?
In final exam, I'm just going to keep first for 5 modules.
Oh, okay. All right. Thank you.
I'm going to make a detailed announcement in just an hour. After I finish this class, I'm going to write about final exam and everything. So you will see the detailed information related to final.
Perfect. Thank you.
Most welcome. And yeah, one more thing, final exam. Yeah, just a minute, just to stay. Oh, sorry, this is another course. Okay, here we go. Can you see my screen?
Yes.
Okay. So here is the, oh, okay, this is not required. So here, this is the, can you see this is a final exam? And
Yes.
the code is right here, BADM 503 summer 2023. And remember that, you know, it will open on August 18th at 6 p.m. and it will be end on August 19th, 11. So you can finish between this time, anytime, you know, 2 hours time. And instead of 2 hours, I put, you know, 2 hours, 15 minutes. But, you know, it can be done in 30 minutes if you studied concept. If you remember the concept, 30 minutes are more than sufficient. So this is just an information that, you know, everything is right here. The code is here, availability and everything. So, and I'm going to make an announcement in just an hour.
So I'm sorry, I'm never taken a quiz through the Eastern stuff. What's the access code for?
Can you see this? Can you see
Yes.
my screen?
Yes, I can see it. I'm just wondering what do we
so
use it for?
so this is the access code. You just just click on this. You need to click on this, and it will ask the access code. So you just copy and just paste here, and you will get inside this. This is a canvas, normal canvas. It is not proctored. It is not like, any security thing. So you just, like you are doing a quiz on MCQ. Every week you are doing MCQ. There
Okay.
you don't need to enter the password, but this is a password protected. Only difference is that, nothing else.
Okay, thank you.
Most welcome. Okay. Thank you so
Thank-
much.
Thank you.
Bye-bye. Good evening.
Thank you.
Bye-bye.
Thank you.
Most welcome. See you in 5:20. Yeah. Okay.